Now, can you solve this question? I have started it.
It's 73. Oh, wait.
73. But 73 is not an option here. Can you check again?
I mean, I didn't calculate it 73.
C4H9OH. 12 into 4 plus 1 into 9 plus 16 plus 1.
Oh,
Uh,
plus 1, I thought into 1.
hmm,
Yeah, 74.
70. Now, the equation for the decomposition of magnesium nitrate is shown. Achha, let me see how we have arranged this one. Now, can you look at this question? A sample of 16 gram of a metal oxide. Now, this question is matching with your book. Can you check the book from where you send me the picture? The same question is here. So can you please join from here?
Okay. How do you do this?
Now start this question. You got this question, right? Sample of what is the relative atomic mass of M. So 16 gram of a metal oxide is reduced to 12.8 gram of the metal. So we know the metal is 12.8. MO, the total is 16. So can you find oxygen? Metal and oxygen together is 16 and alone metal is 12.8. So how much oxygen will be there? Look, MO means metal and oxygen is 16 gram. Alone metal is 12.8 gram. So how much oxygen will be there? Metal and oxygen together is 16. Alone metal is 12.8. So can you tell me what is the oxygen mass?
3.2.
Yes. So oxygen will be 16 minus 12.8, 3.2 gram. Now, how we find the relative atomic mass of the M? He says, what is the relative atomic mass of M? I have I have oxygen, I have the metal, so we do not know. We can find it now. The sample of 16 gram is the total metal oxide.
How do you do this?
You have to use, because he says a sample of 16 grams. So we know oxygen, but what is the molar mass of oxygen? What is the relative atomic mass of oxygen?
It's 16.
Good. Now make a ratio. Oxygen. What is the relative atomic mass of oxygen? That is 16. So I start with oxygen. The relative atomic mass of oxygen is 16. So I will apply a ratio. Look, my oxygen AR is equal to 16, and 16 is giving me 3.2. Now, the other metal M, I do not know the AR. So I suppose AR is equal to X, and it's here, it is 12.8. So apply ratio method. Look at the ratio method.
I got 64.
Sorry, how much?
64. B.
B.
Yeah, 64.
Okay.
Isn't M magnesium?
The voice is low. Can you speak a bit loud? Can you try to, because I couldn't get you?
Isn't M magnesium?
No, no, no. Symbol of magnesium is not M. Symbol of magnesium is Mg.
Oh, yeah. Okay.
So you have to keep on using the periodic table until you get a good grip on periodic table. Acha, let me see. I think that question was also there in the screen you have shared with me. Look, the equation for the I think this question is also with you. The equation for the reaction between calcium carbonate and hydrochloric acid is shown. How many moles of calcium carbonate will give 24 cm cube of CO2 when reacted with an excess of the acid? Now read the question. One, two, one, one, one. This is the balancing coming from the equation. Now, what's the formula for volume of a gas?
N24.
Ah,
DMQ.
or dmq. So volume is equal to N into 24 dmq. But we have the working, we are getting the working in cm cube. So how to manage that?
Divide by 1000.
Yes. So can you try this question? I have made the initial working. So please try this question. I'm just coming in a minute. Please try this question. Now, did you try this question?
For 0.024 dm cube, but how do you find the number of moles?
No, I actually some issue is coming with the voice today. Maybe I'm using some different device. Actually, this is how you get the number of moles. This is how you get number of moles. Then after getting number of moles, what you should do? Can you hear me?
Yes, sir.
Mikhail, what I should do now? I got the moles of carbon dioxide. Look, I got the moles of carbon dioxide and I need calcium carbonate. Calcium carbonate is CaCO3. So how can I find the calcium carbonate moles now?
How did you find the moles?
Volume is equal to N into 24,000. Volume is given. Can you see the screen? Volume is
Yeah.
20. So look at the working for CO2 moles.
Why 24,000? Isn't it 24?
No, but 24 dm cube, na? But here it is cm cube. So when you convert cm cube, when you convert dm cube to cm cube, you multiply by 1,000.
Okay.
Now,
What's 10
and
to the power
I'm
minus
waiting for
3?
you to tell me the last step.
So the answer is 0.01. See?
But
And see?
0.001, 0.001, 0.001 is the 0.001 is the mole for the CO2. Are you using the ratio? Look, CO2 moles, please focus on the screen, Mikhail. CO2
Wait,
moles,
wait, wait, wait.
CO2
Okay.
moles are 10 power minus 3. So what about the moles of calcium carbonate? Number of moles of carbon dioxide is 0.001. And
No,
the
0.01.
hmm,
Isn't it 0.01, not 30? Because it's 10, right? 10 to the power minus 3.
you can use a calculator, one upon 1,000.
Okay.
Look at the ratio. Ratio is 1:1. Acha, now how I know ratio is 1:1? Yes, Mikhail, how I know ratio is 1:1?
Because in the equation is 1:1.
Yes. Now do this working. I hope you're working with me on your on your book. The main benefit is to work on the book. Now look at this question. This is also present in your book. Analysis of a compound formed between magnesium and nitrogen. It contained 14.4 gram magnesium and 5.6 gram of nitrogen. What is the empirical formula of the compound? What's the procedure for empirical formula? Let us repeat this one. Please write with me on your book. Do the working on your book so you have a habit of writing on the book and you know that you have a limited space. The mass of magnesium is 14. The mass of magnesium is 14.4 gram and the mass of oxygen is 5.6 gram. How we make the empirical formula? Now we divide by MR. Can you tell me the MR? Can you tell me the MR from the periodic table? The relative atomic mass. Open the periodic table, group 2. Yes, I'm waiting.
Do I just divide 14.4 by 5.6?
Hey, why? No, I'm saying divide by relative atomic mass, Mikhail. Look at the
Oh,
periodic table. What is the relative atomic mass of magnesium?
magnesium is 12, oxygen is 3, magnesium is 24,
Hmm,
oxygen is 16.
okay. Okay, now calculator 14.4 upon 24.
0.6. 0.6 or 0.35.
Now
0.6 divided by 0.35.
divide by the smallest. Can you divide by smallest now?
1.7 to the ratio 1. So 2 ratio 1.
This is the last hope, but I was thinking that if I take, look, if I take 2 is to 1, 2 is to 1 is not matching. This is an MCQ, so no option is coming 2 is to 1. You have to think about any other multiple. Yes, okay. Any number close to it. 2 is to 1 is not working. So even rounding 1.7, we have to think about any other number. Oh, there is a mistake. Look, can you read what is 5.6 gram of what? Look what the mistake is there. Look at this. Read the question and see what is the element of 5.6 gram. Mikhail, can you hear me?
Yes.
So please read the question again and see what is the mistake. Read 1.6. I make an arrow for you. Read from here. Please read it. Are you there?
Yes.
Can you please read it? 5.6 gram of
Nitrogen.
nitrogen. And what element I have taken down?
Shannon. Oh, you wrote oxygen.
Yes. This is a mistake, so please identify the mistake and quickly repair it. This is a mistake, so we have to repeat our calculation.
Yeah.
What is the relative atomic, what's the relative atomic mass of nitrogen? What is the relative atomic mass of nitrogen from the periodic table?
Nitrogen is 14. 14.
Okay. 14. Now, can you divide it? So, Mikhail, I'm waiting. Can you please be quick? 5.6 upon 14. One line division is there.
Yeah.
Please be quick. We are the class is getting over. We have limited time. Already exams are on our head.
0.4.
0.4.
1.5 ratio 1.
I'm getting 2 upon 3 here and 1 here.
Yeah, no. 1.5 and 1.5, yeah, 2. Isn't it 2 and 1?
You're getting 1.5.
Yeah, 1.5 ratio 1.
So you can make it 3 upon 2. Then it will become 3:2, magnesium 3 and nitrogen 2. Copy this working. Please do all the work with me. The purpose of the book.
How is it? How is it 3 ratio 2?
Because when you simplify 1.5 is to 1, you multiply it by 2 or 3, whatever you get it. Actually, it is 3 upon 2 is to 1. Na? So when you simplify 3 upon 2 upon 1, it becomes 3 upon 2.
But 0.6 divided by 0.4 is 1.5. So 1.5 ratio 1.
1.5 ratio 1 is 3 is to 2. Na? 1.5 means
Oh,
1.5 means 3 upon 2.
okay. Yeah, I wrote this down already.
Okay. Have you copied it? Please do the working side by side with me.
Yeah, I did.
Okay. Now look at this question. An excess of zinc. Please read the question.
The maximum volume of hydrogen. Volume. Um,
Okay.
Okay, so we use HCl to find the volume of hydrogen.
Hmm.
I mean,
100 cm cube is the volume. 1 mole per dm cube is the concentration. The equation for the reaction is given 1, 2, 1, 1. Again, I hope that you're writing with me.
yeah,
Then what's the maximum volume of hydrogen evolved at room temperature? So first we apply the formula N is equal to Cv. N is equal to concentration is 1. Volume is 100.
but isn't it the volume of zinc and concentration of HCl?
So I'm finding the moles of HCl now.
But the volume is of zinc.
Volume of zinc? No. How can no make a concept clear?
Oh,
A zinc is a solid. Solids do not have volume. This is a language. The excess of zinc is added 200 cm cube.
yeah, sorry.
Okay. Now can you do this calculation?
0.1 into 1, 0.1.
Okay. Now HCl and hydrogen make a connection.
Okay, so 0.21, 0.1x. 0.1 divided by 2.
Okay. Number of moles of hydrogen will be 0.1 upon 2.
0.05.
Okay. And what's the formula for volume?
924 dm cube, so 0.05 into 24. 1.2. 1.2 dm cube.
Do the working like this in your book.
Okay. Okay, done.
Okay, good. Now look at look at this question. Is this question there?
I don't think so.
Benzene is a liquid with molecular formula. It should be around this question. The picture you have sent me.
Yeah, I think I found it.
You found it?
Yeah.
Very good. Now start it. Benzene is a liquid with molecular formula C6H6. Ethene is a gas with molecular formula this. He says this is a theory question. We have to eliminate one by one. One mole of benzene and 1 mole of ethene contain the same number of atoms. 1 mole of any substance contain number of atoms equal to what?
It's not A, but actually,
Sorry?
maybe it is A.
Okay. What about other options? Did you knock them out?
I mean, I think um, volume, the volume formula is for gas only, right?
Hmm?
Is the volume formula for gas only? N24
One
dm
mole of
cube.
1 mole of ethene both have a volume 24 dm cube. That's wrong because the volume rule is applied for gas. Benzene
Yeah,
is liquid. Both benzene and ethene have the same empirical formula. Its empirical formula
I
will
think it might be C because 6, yeah, 1, 1, and 1. Wait, no, it's 1, 2.
that's also wrong. The number of carbon atoms in 0.5 mole of ethene is equal to the Avogadro constant. We can find it. So
What?
find it that 0.5 mole of ethene, number of carbon atoms, there are in 1 mole, there are 2 carbon in ethene. 1 mole of ethene has in 1 mole of ethene, there are 2 carbon atoms. So let me write here 1 mole of ethene has 2 carbon atoms. So when I say 0.5 mole, it will mean 1 so it's a tie between A and D. He is trapping you in A by the word atoms. Benzene is not an atom, benzene is a molecule. Actually, the word should be not atom here, the word should be molecules. The examiners are very clever, so they trap on little words. So A is also wrong. So D is the right answer. So in this way, you should try some questions like after the class, if you can sit for 10 minutes and 15 minutes and do try some questions from your book. Today, you have done some MCQs with me. Stoichiometry is a very important topic, very challenging topic. So do some questions today and try to do the questions from the topics which we have done. Then I'm thinking to make in the next class, make a list what topics we have done, what topics we haven't done, so we can focus on them. So right now we are stopping here and we will inshallah continue in our next class. Allah Hafiz.
Office.